Hi guys, in continuing with our energy systems discussions, today we're going to talk about aerobic glycolysis or oxidative phosphorylation. Either way, it's the aerobic system, the one that uses oxygen. So we've spoken about creatine phosphate system, we've spoken about anaerobic glycolysis, and now we're going to talk about that final energy system that needs oxygen. Okay, so in the aerobic energy system, the primary source of energy is glycogen, glucose, fats, and proteins. Now, some of these fats, for example, exist within the muscle, in between muscular fibres, and then the proteins can actually come from muscle breakdown. Okay, that's in extreme cases. Like in a marathon, you're actually starting to use your own protein from your own muscle breakdown to give you enough energy to continue. Duration of activity is generally over 3 minutes. Now, as we've discussed in all of the other energy system videos, these systems don't work in isolation. So it's not like at 3 minutes of activity, all of a sudden the aerobic energy system kicks in. It doesn't work like that. It's just that once you get past that 3 minutes of physical activity, the aerobic energy system will be the system that contributes to the majority of the energy reactions that are occurring. Sporting events may include walking, jogging, swimming, walking upstairs, things like that. We're talking lower intensity so that you can go for longer. Having said that, when you think of a marathon, they're running at such a high intensity. So yes, they are using the aerobic energy system, but they're definitely also using anaerobic glycolysis at the elite level in a marathon event. So that's where intensity comes into things too. So intensity and duration are the two main factors that contribute to which energy system you're using. Advantages of the aerobic system, aerobic using oxygen, is the large output of energy that you can get over a long period of time, and the fact that it removes lactic acid, so it can actually use it as and recycle it as an energy source. But again, this happens at low intensities. That's why, for example, if you're a runner and you've just done a high intensity interval session, it's a good idea to go for a lengthy jog afterwards, because that aids in the removal of lactic acid. You're changing energy systems there. The majority of energy system that will be working is the aerobic system at that point. It will be recycling the lactic out of your muscles. Okay. Limiting factors of this system: lung function. So if you have a decreased lung function, then your ability to deliver oxygen into the blood and to the muscle is going to be limited. Maximum blood flow. So you think about, for example, your heart rate and the amount of blood that it pumps in one beat. That's a limiting factor. Oxygen availability. So if you're training at altitude, that'll be an issue. And that obviously people play on that for a certain reason. But we'll talk about that probably in class. And the excessive energy demands. And I'll talk about that in this slide here. So we've got a bit of a pictorial depiction here of what is going on. Okay, so you've got oxygen that is required for this chemical reaction to occur. You need proteins, fats, glycogen that's stored in muscle, okay, so intramuscular, which all contribute to the energy that's required for ADP and phosphate to bond, okay, and then the energy is released when the extra phosphate molecule is dropped, okay, and then the byproducts are carbon dioxide and water. Okay, and it's just important to note there that that happens in the mitochondrion. Just a little thing to note about where it's happening in the cell. So again, these are the inputs here: protein, oxygen, fats, glycogen. This reaction requires energy, so that contributes to the energy to allow the reaction to occur, to release enough energy for the muscular contraction. And you've got some outputs there. So basically that's the aerobic energy system in a nutshell. Blood lactate levels remain relatively low. That's important to note. Primary source of energy for exercising lasting longer than 10 minutes. Okay, and again, providing a few things so that you've got enough so that your mitochondria are sufficient in your muscles, for example, and that's to do with training adaptations. And don't worry about too much about these things in terms of senior PE. It's the primary source of energy for exercise that is performed at an intensity lower than that of anaerobic glycolysis. Okay, intensity, duration, they're important, and remember, these systems never work in isolation. So please go away, have a look at some more information from a variety of sources, because there will be differing information out there. Take notes, and good luck.